Question number 4A is a non-calculator question. And it seems like it should be calculator because it's not one of your memorized values. And then part B is the calculator part. So, again, we're going to use reference angles and CAS rule a lot in this unit. If we know that cos of the angle alpha, there's a new Greek letter for you for the day, is negative 4/5, according to your CAS rule, where could it be? Well, CAS rule tells us where things are positive.
Quadrant 3.
So yes, it's going to be 2 and 3 because it can't be 1 and it can't be 4. Well, you're good at this. You sure you don't like trig?
I want to get myself.
Okay. I was hoping for a more positive response.
Now your video's gonna get taken down on
Yeah.
YouTube.
I can try again.
I'm scared. So quadrant 2 and quadrant 3. So you could draw a picture. You know it could be in quadrant 2, and you know it could be in quadrant 3. We know that this is our reference angle here, and this is our reference angle there. And from grade 10 math, you know that cos is the adjacent over the hypotenuse. So if I drew a triangle and I made this side 4, this side would have to be 5. And here, if I made a triangle, my adjacent side is 4, this side would have to be 5.
Oh yeah.
Because cos is adjacent over hypotenuse. And if it's true for the angle alpha, oops, I have a little typo. You see my typo? My angle isn't theta, it is alpha, so I should have these little things. Our alpha reference angle.
Oh, what's alpha?
Alpha is another Greek letter that we're using as a variable.
Why do we use it?
The three most common for trigonometry, we like to use Greek letters. Theta is the most common. Then after theta, if you use 2,
Theta.
alpha and beta are the next 2 most common used variables for angles. Don't know why. Historically, that's just what's used.
That
So
doesn't change it. You should learn.
you could have x. Could learn some new letters, right? I like the Greek letter nu because it's kind of an N, but then kind of ends with a U, and if the letter is called nu, it's like super cool, that one. Same thing with mu.
It's moving.
There's nu and mu. There's new Greek letters for your day. Then there's, I don't even know what this one's. Oh, I don't even know if I can draw it anymore.
It's a signal.
Yeah, it's sigma.
That one. Woo! I don't know what that is, but that's
That's a weird
Sigma and delta.
signal.
Okay, anyways, we're not going to learn the Greek alphabet all today. But if you did a squared plus b squared equals c squared, this is your 3, 4, 5 triangle. 25 minus 16 is 9, so that side has to be 3. A squared plus b squared equals c squared. And if you draw the triangle, you could determine that sine of alpha here would be 3/5, and sine of alpha here in quadrant 3 would be negative 3/5. And tan of alpha in quadrant 2 would be negative 3/4, and tan of alpha in quadrant 3 would be positive 3/4. That's what 4A is asking. Can you tell me what sine of alpha is? Can you tell me what tan of alpha is? And you can do that without a calculator, because all you need to do is draw your triangle, label adjacent over hypotenuse, because you know that from cos, and do a squared plus b squared to find this final sum. Part B says, to the nearest degree, we should solve for this. So I had cos of alpha equals -4/5. I find my reference angle. By doing cos inverse of +4/5. Go to my calculator. Any guesses?
54.
All right.
67.
How about 37.87? Oh, 36.87. I was so close.
I'm close.
36.87. Does this one say to the nearest degree?
Yes.
So 37 degrees will be these reference angles. And we want to find the actual angle alpha will be this one and this one. Can you see here that it will be, oops, alpha. See, we write theta too much. My angle alpha will equal 180 minus my reference angle. And here alpha will equal 180 plus my reference angle. (180 minus 37), 143 degrees, and 180 plus 37, 217 degrees. So, also circle question number 13.